It was only like one lost minute, so it wasn't the worst I've ever done. I would start it, but I'm distracted by by his hickey. How was that? Just kidding. He's a wrestler. Right here. No.
That was from wrestling.
That's what I said in high school too. Mom, we were just wrestling. What? No, it's fine. I'm just joking. Okay. Anyway. I'm sorry, that was not very nice. Okay, if A plus B forms AB, but now all of a sudden there's a ton of AB, and let's say just an AB got in the way of this happening. Well, the A gets blocked by the AB, so it can't form with B to make another AB. I know that sounds weird, but these go down, this goes up, so the rate decreases. All right, now a plot of concentration versus time for this reaction yields a curve that looks like this. All right, it's not linear for sure. All right, the slope of a line tangent to the curve at any point is the instantaneous rate at that time. Have you guys, okay, hold on. Well, we don't need any calculus for this, but yes, calculus is finding this stuff. Raise your hands if you've found a tangent line before. Okay, well, you don't have to. You just need to know what it is. A tangent. How about screw it? Okay. Yeah, it has to actually touch one single point, but no more than one point. So the way we do it, you've done it before. You probably did it in some math class where you found like some sort of statistic, but you make it so it just barely touches somewhere. So like right here, and then you have your triangle, your rise over your run, and you can calculate your slope. And for that one point at which it touches, that would be the instantaneous rate. Right. Yep. So now we don't have to do all that math. We have other ways to find it out, but just know that's how we would find instantaneous rate from a given table. All right, next. All reactions slow down over time. Therefore, the best indicator of the rate of a reaction is the instantaneous rate near the beginning. So when we talk about the rate of a reaction, it's usually right at the very start, not when all the reactants are gone and they're really hard to find. We care more about the start. So we will be finding rates today. Today starts the math that I don't know why, but I find it really fun. But I have a problem. I'm psycho. I like math. Okay, so just know we always measure it towards the very start of the curve, not lower. I see lots of people writing, so I'll refresh. Why wouldn't you just take the average rate? Because it's not accurate. Well, it's accurate. It's the average, but the average might not be that important because maybe it's super fast here and super slow here. And if you took the average, like your airbag, they're like, well, the average that it would inflate at is here. Well, it's only going to inflate for like 3 milliseconds. So I'm going to care about the rate right here. This would have no bearing on how fast my airbag would inflate. So we, uh-huh. Yep. Okay. So reaction rates and stoichiometry. If you've watched the AP videos, you have seen this. This is a really important concept. It's not that complicated, but it definitely is something you need to understand. So if you are given a rate, so let me come back over here first. So if I have a reaction and I tell you that the rate is equal to like 7.1 molarity seconds to the -1, which is molarity per second. Okay, this is a positive value, so that would be the rate of appearance. And if I have my equation, A plus B goes to 2C, this would be the rate of appearance of this, because these would be negative values, right? So just based on all this information, you could tell me the rate of disappearance of A. Do you know what it would be? What's that? All right, it would be half of 7.1, because for every two of these, 1 and 1 disappears. So you should always balance everything. So A changes at a rate of 1 to 2, or half the speed. So the rate for A is 6.55, not 6.55, 3.6, no, 3.55. I'm having a heart attack here.
Yeah, 3.5. Oh, so it'll just give you like the rate for this molecule in the product with this once the.
It might not tell you if it's a product or reactant,
Okay.
but it would probably say the rate for C is. But in this one, I didn't even need to give you that, because C would be the only one that has a positive value. The other two would be a negative. So this is the rate of A. What would the rate of B be? Okay. This S to the -1, get used to it. They use it a lot in this chapter. It means molarity per second, because -1 drops something into the denominator. All right, so coming here, it might look a little bit different, but the rate of appearance of A is equal to the change in A, the negative, I should say, change in A over time. The rate of appearance of B is the rate of B over time. Oh, I wrote it different, but it's fine, because that's a product. That's why this one's positive. Then appearance of C is the rate of C divided by time. The rate of disappearance of A is equal to the rate of appearance of B and half the rate of appearance of C. So we will use stoichiometry. That means we first start with a balanced reaction. And if we have the rate for one of them, we can get the rate for all of them. Okay. You try this while I get my TA working. All right, here we go. Do you have an answer? Tell your partner. All right, let's get after this.
Wait, why is D like that?
Why what?
Why is D like that? That doesn't make sense. Don't you gotta times it?
Why is D? I just didn't want to write this all out.
We're just ignoring it.
Well, the dot, dot, dot means that stuff right there. So I'm not going to worry about it. All right, so if D is 2.5, E is how many times 2.5? 3. So that is 7.5 times 10 to the negative 2 molarities per second. If no, you can if you feel like it.
Maybe I'm not, but yeah, but I think I am too, because so if you have like a 3, to say it gave you E, right?
Okay.
And it had a 3 in front of it.
Okay.
Then you would just divide by 2 if you wanted to find that.
Yes.
Yes. Okay. And then you times it.
Well, sorry, I got to say that again. Did you say it gave me E?
Give me E. Let's just say E is like 2.
2.
And then it says like find F. You can divide 2 by 2.
No.
Oh, you divide it by 3 and then 10 divide by 2.
There you go. I have a 2/3 ratio. So I'd have a 3 and a 2. I'd have what I don't want. That's the coefficient in front of E. And then I have what I do want, which is the coefficient there. So we're doing this same process. We're just doing it in our head since it's easy numbers. But yeah, be careful there. Okay. Well,
Yeah, they both be negative.
yeah. Yeah, and that's fine. It says this is the rate of disappearance. So yeah, we can put a negative. That's fine. If it says what is the rate of disappearance, it's already accounting for the negative. So you wouldn't be marked wrong either way. The rate of appearance of F would be 2 times D, right? So that would be a positive 5. Now, if it's confusing math, we can do these. We can do it the same way we've always done it with a picket fence. We take the given, so this one, D was 2.5. I'm just going to put D right there. Are you okay with that? That's representing the rate of D, right? I use the coefficient in front of D, which is a 1. Then I use the coefficient in front of what I want, which is E, which is a 3, and it was the 7.5. Okay, so if you can't just do it in your head, use the coefficient of the given down here, the coefficient of the wanted up here, and it works every time. Yes, Judah. Right here?
Yeah.
Yeah, I put the negative right here. But also, the reason why this doesn't give you a negative right here is because it is stating that it is a disappearance. So it's fine. What? Yeah, but on this problem, if you didn't put a negative, you would not get it wrong. You could put all these particular values as just a positive value because it's already told you. We know it's disappearing because the problem told me. I know the other one's appearing because it told me. So I mean it's tricky, but both would be fine on that particular example. Okay, here we go. Another one. All right. Do you need some scissors? All right. Oh, this one's easy money. Right. These are both cut from the AP video. How fun is that? Whatever you feel like. Oh, hey, they came here yesterday to take a picture of your hair. I know that sounds weird. Walk towards me. Get that little note right there. I think it was it best hair?
Were we assigned videos like for
I didn't put them on there, but you should watch them. I can upload them. Well, I can link them. Okay, anyway, here we go. What? That was yesterday. Oh, that's funny. I didn't even read it. Okay, head down there. We'll try. And you have your hair in a braid. Unreal. I know they do. Go down there and protest and say, I'll wear my best hair tomorrow. Yeah, my wife's like that. It's a second day hair day, Tom. Like, okay, fine. I don't know what that means, but okay. So the problems are easy if they give you this, which is a 1, right? It's not hard at all. What's the initial rate of decrease in y? Well, it's going to be
Double.
2 times whatever x is. Why are you K-ing me so loud? I feel like that was okay.
No, they just put negative, but it says the rate of decrease.
Right. Okay. Not that bad, I hope. All right. I think this is the last example. Fire away. This is also from the video. This is a very typical AP question. I can't make that much bigger. Yeah, we're out of luck. Hopefully you can read that.
I can't really give you a yes, no, and then why.
Yeah, well, there's all sorts of stuff on here that doesn't matter for answering this.
I just tried the ACT. The very first question in the science was chemistry. And it was about chapter.
You're welcome.
Yeah, I still got this right.
When you get a 30 on your ACT, you got to bring me a Mountain Dew. If anyone gets a 19, let me know and I'll buy you a Mountain Dew.
It's a 19. Wait, we got our ACTs coming up.
Shh. Answer the question. Are you done?
He said, I love.
You're probably done. What letter? Raise your hand if you think it's A, B, C, D. All right. Well, it is D.
Oh, I thought you said B for a second.
We'll learn the order is here in like 5 minutes. You do not need this table even 1 iota. What do you need?
You just need the formula.
You need this and that and that. Now, it didn't ask about X, Y, but you just need the balanced reaction. So it's just trying to trick you. Now, this is, you'll see this table a lot in what we're about to learn. So it's not really trying to trick you. This would be a separate question that came from the math, which comes from a table like this. Yes, ma'am. That won't matter. That might say how fast the overall reaction, but still twice as much Y will be consumed than X, no matter what the ratio is.
Well, what if they have different masses?
Doesn't matter.
Because you're still eating more Y in proportion to X.
If it said something like
Speed-wise.
moles, then that's possible, but they're not going to make you compare a mole to a gram and then compare the rates. Okay, so here we go. In summary, the kinetics of a chemical reaction is defined as the rate at which an amount of reactant is converted to products per unit of time. Somewhere I screwed up my English there, but whatever. The rates of change of reactant and product concentrations are determined by the stoichiometry in the balanced chemical equation. All right, these graphs, by the way, this is not something that's tested usually, but the shape of this graph can also tell you, you will see that the red and the blue roughly changed the same, but the green changed twice as much as the red, roughly.
We won't be tested on this.
Well, you'll definitely be tested on this,
Like the graph.
but you don't have to go from a graph to a balanced equation, but you could tell it's a 1, 1, 2 just from the picture.
Okay, so like, will the AP test just put up
It could, for sure. What do we have? Ooh,
Dibs.
you're welcome. All right, next, here we go. This is super easy. If you get this wrong on the next test, I'll be frustrated. Ready, go. 30 seconds. Oh, that felt good. Depends on what I've been doing. All right, here we go. The answer's A, because highest coefficient.
I don't want to feel dumb.
All right.
Imagine if you were so certain it was A and it was like.
Well, that's the story of 1050 when I took it. Math. Oh my. Like, I got this. The teacher, hey, eat it. All right. You know, you're not allowed to speak anymore, Grace Johnson. Math 1050 for non-geniuses is hard.
I'm taking next time.
Hey, by the way, they changed it. They changed it like 5 years ago.
I don't know. Probably.
Okay. I need you to focus from now on. I need you to participate. This is absolutely imperative. What is it? No,
No.
just don't break them. They're $8 a piece.
Oh, God.
Should I just put them away in there?
Yeah, they go on the middle table, like at the far right, in a little clear thing. It's not very organized. Just test tubes. All right. Those are called blast tubes. They're very thick walled. We use them for 2 demonstrations because if they broke while you did the demonstration, I would be very injured. Okay, concentration and rate. Okay, maybe she is being a little loud. Just kidding. All right. You need to know from now on, I'll come back to this slide in a second, but we have a thing called a rate law. A rate law is really the mathematical equation that defines the rate. The rate law is always in this format. Rate equals K. K is a constant. Now, this is where science sort of gets weird. It's a constant that is different for every single reaction and every single different temperature.
So they have to give it to us?
No, you're going to figure it out. All right, so just shut up and here we go. Rate will be equal to K. And if this was just a 2 reactant thing, we'll call it A and B.
That satisfies my.
She's my TA. She has the right to do whatever she feels like. All right. The rate law looks like this. Rate equals K times the concentration of your reactants. What? It's super fun. Well, people, let me finish. We're not even, we've taken 1 step on the height. I can't teach under these conditions.
Anyways, the concentration of A.
Okay, but you guys need to be quiet. This is absolutely on your test. This is absolutely something that everyone can do in here, no matter how dumb you are. But if you don't pay attention, everyone will struggle, even the front row. Rate is equal to K times the concentration of A to the X, B to the Y. On a multiple choice question we had a second ago, it talked about the order. All right, we haven't learned about order, but we're about to. All right, so what we are going to do, we are going to use tables of data to figure out the rate law. Once we figure out the rate law, then we can put in the data from the table and solve for K. Once we know K, we can solve for any rate given any concentrations. It's pretty dang cool. So, hey, I feel like I did this already. So one can gain information about the rate of a reaction by seeing how the rate changes with changes in concentration. So we're going to see tables where we scientifically determine the rate when we change the concentration of our two reactants. Based on how the rate changes, we can determine what these numbers are, which is the order or the exponents. Okay, now I need you to really stick with me. So here's our goals. We're going to use data tables to determine the reaction rate law. And this is where we're going to find the exponents. Then we're going to use the rate law that we just found out to solve for K. Then once we have K, we will use it and the rate law to solve for unknown concentrations or rate, depending on whatever I feel like.
So do we have a second equation that goes along with it?
Not really. All right, so I just want the table. So this is how we do this process. And please, 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 please pay attention. We're using this table to find the order of our reactants. So I already know the two things in my reaction are this. So I could write the overall rate law. I could say that rate is equal to K times the concentration of NH4 plus raised to some exponent that I don't know. That's my goal. Times the concentration of NO2 minus raised to some exponent I don't know. So this process we're about to do, we're simply finding these exponents right here. That's the whole goal. You with me? Okay, let me come back a second. All right. I want you to think about something. If I have, that's ugly, that's annoying me. I'm going to be changing these numbers and raising them to some exponent. And then let's just think about the math here. If I have a 2 in here and I raise it to a 0, what number do I get? I get 1. So if no matter what I put in here, what's my answer going to be? 1. All right, what if I raise this to a 1? What do I get? A 2. Or a 3, it would be a 4, 4. So if it's first order, whatever my change is also represented in my answer.
So it's the exact same.
It's the exact same. If it's a 0 order, whatever my change is, I always get a 1. Like there's no change. Okay, but then if it's to the second power, if I put this here, what do I get? A 4. If I get a 3, I get a 9. So I have an exponential change now. Sort of with me? So if I were to double my concentration here, I would quadruple my rate. That's what this is. If it's to the third power, whatever my change is in here, the rate is 8 times that because it'd be 2 cubed. Okay, so now try and follow this logic as we work through this problem. So this is how you do these problems. You look at both of these and you try and find one where one of the two reactants is held constant. This is a 2 and that's a 2. So this over here, though, I have doubled the concentration. Is everyone okay with that?
Yeah.
Okay. So this investigation, I'm finding the exponent for NH4 here. You always are finding the exponent with the thing that that changed. All right. So I doubled the concentration of NH4, and then I look over here, and what happened to the rate? It also doubled. Well, what exponent do you raise a number to that keeps it the same number? Not 0. 0 turns everything into a 1. So this would be a 1. All right. So it's the exponent of 1.
And then would you do 0 for the next one because it doesn't change?
No, no, not yet. Okay, so the exponent, all I know so far is that this reaction is first order with respect to NH4. Now, the next thing I do is I find a place where this one is kept the same and this one is changed. So same, but doubled here, right? 2x. And what happened between these two numbers? It also doubled. So that means this exponent is a 1. So now I know that the rate is equal, whatever, that's a t, equals k NH4 plus to the first power times NO2 minus to the first power. This is my rate law. What was the next goal? Do you remember? To find out what K is. All right. So to figure out what K is, I pick a row and plug everything in. So I might as well pick the first row. Actually, I'm not going to. I'm going to pick the bottom row because I need to scroll. So the bottom row, I just put everything in. So my rate is the answer on the right. 43.3 times 10 to the negative 7 is equal to K times 0.2 to the first times 0.0808 to the first. So K will be equal to 43.3 times 10 to the negative 7 divided by 0.2 times 0.0808. Grace, you're typing?
Oh, yes.
Oh, I heard a calculator noise.
It could have been me.
Now, everybody, you can borrow my calculators. For chapter 14, you have to have an upper level calculator. You just have to, because, and not for this problem, but coming up, you have to be able to use a calculator, but you can put information into data tables in the list function and get statistics from it. Now you can borrow mine, but if your parents have the money, it might be a good time to convince them you need a TI 84 or higher. Okay, did anyone type this in?
I got, did anyone else get this like 0.00026796? I might not know how to use it.
Okay, what'd you get?
I haven't converted to, never mind.
You don't need
2.7
a,
times 10 to the negative 184.
okay, that would be K. Okay, now, you know what I can do once I have K?
Then you can plug it in.
I can do whatever I feel like. I can do whatever I feel like. So remember this number, 2.7 times 10 to the negative 4. It might be off the screen. Okay, I want to know the rate then. If I have 0.045 and 0.25, tell me my rate with these two initial concentrations. It's okay.
Oh, okay.
Super, have you learned how to use a calculator yet?
No, I haven't.
It's all right. He's not the first kid. I don't know. Open it up. If it's, have you opened a container of beakers yet?
Yeah, that we did a deal with it.
Okay, open that up and see what it is. I'm not sure that it really is Miller's because I put in all the order.
Oh, 43.3 second. I mean, that function. Second easy.
You're confusing me what you're saying.
Why not? That right?
Anyone have a rate yet? Thanks.
0.0375.
Start over. She popped bubbles at the wrong time.
Not for the second. 3.0375 times 10 to the negative 6. Yeah.
Okay, I lost track, but we're just going to call it 3 point something times 10 to the negative 6. Okay. Now, here we go.
Are you in the right mode?
A microscope, what? Yeah, go put that on his desk. He has a sub. Just walk in there and slide it on his desk.
How do you go with your second round shot?
I had a very rough night last night, but I'm alive now. Okay, here we go. I got super bad chills. I had a fever of 105. No, sorry, 100.5.
With your,
Yeah,
with the vaccine?
yeah. 100.5. That's not that high. I just said it wrong. But then I just sweat to death in my bed and I felt fine. Okay, here we go. We have 5 minutes. Same process. These two here are held the same. These two here are 2 times. What does the rate do? It quadruples. So in exponent land, how does a 2 become a 4?
You erase it there too.
I square it. So C2O4 minus, or 2 minus, is now raised to the second. You okay with that?
Are we
Okay.
gonna do one on our own after that?
There's 100 of them. Now this is held the same. And you got to be careful. This one doubles going up. So what happens here?
Would that be a negative?
No,
Half.
Oh, it doubles up going up.
it did half, but I wouldn't do half. You're just moving up the table. The direction you move on the table doesn't matter.
Oh, okay.
So when it went up, it roughly got 2 times, right?
So that'd be a 1.
So that means this one's a 1. So pretty quickly, we now know the rate is equal to K times HgCl2 to the first times C2O4 minus 2 to the second. This is my rate law. What would be the next step?
To plug them in.
Don't plug them in.
Define K.
Yeah, define K.
Okay,
I mean,
okay.
plug 'em in by
Okay, so find K. So K equals rate divided by this stuff.
Oh, yeah.
HgCl2 to the first, C2O4 to negative 2 to the second. And then I'm going to erase this. All I did is I took that part over. You okay with that? Okay, now I'm going to plug it in. I'll pick the top row. I usually always pick the top row. So the rate is 0.52 times 10 to the negative 4 over, and I'm just putting these pieces in just on this side. So then I have the concentration of 0.0836, and that's to the first, and then 0.202, and that's squared, and that will tell me what K equals. It's extremely convenient to have a calculator that does parentheses. Do you know where it goes? Nope. You're the best. Oh, did you get that? Leave that big ball. You're good. Did you open that acid? Okay, don't. You're very smart.
So
I think I got it.
The bottom stays as the initial. So like the 0.202 always stays as the first initial given thing. But
Well,
the
you could,
exponent is all we find out.
yep,
Like I'm just talking about like the.
yeah, we use this process to just find exponents.
Yeah. Okay.
Then to find k, we pick whatever row we want and just plug it all in.
Wait. Oh, so you could take point and then 0.404. Raise to the 2 on the bottom. That would be-
I could,
Wouldn't that be a different number though?
No.
but I'd have a different rate. You can,
Oh,
any of these top 3 rows you plug in, you'll get the same value for k.
okay.
Did anyone get this one?
Yes.
Yes.
What is it?
It's
Oh.
0.0155.
152.
All right, we're gonna call that good enough.
152.
I didn't get it open.
A lot of people did. Okay, then you just plug it in and solve for that.
Oh, I didn't know this was my solid.
Yep, you would have 1.27 times 10 to the negative 4 equals 0.015. That's k
And then you would just go
times 0.0316 raised to the first times x squared. So you take both these under and find the square root of that answer.
and then I could do the computation of the
Right.
Can I come in after school?
You're still not done?
No.
How on earth are you not done?